2.1 The distance and midpoint formula. You are going to have to memorize these formulas for the test, so don't even ask. You're not going to get formulas from me. If you don't have them memorized by now, what you should do is every time we do an example, make sure you're writing the formula down. Every time you do your homework, write down the formula. And I promise by the end of that you will have it memorized. But what if you don't? And it's okay if you don't. You might just have to work a little harder to remember formulas. I understand it could be hard sometimes. What I would suggest is make flashcards. Flashcards are going to be the greatest gift that you can do to yourself if you need to take that extra step to help you, get concepts and formulas down. And don't feel ashamed if you have to make flashcards. We always have to make them, especially like biology, anatomy, chemistry, stuff like that. Because it's hard. You need to practice and practice and practice. So the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And the midpoint formula is an actual point, and how do you get that is x1 plus x2 over 2 and y1 plus y2 over 2. So let's find the distance d between the 2 points, negative 4, 5, and 3, 2. So since it says distance, I know I'm going to use the distance formula. So the distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And just because it said distance, find the distance, it let me know that I need to do the distance formula. And anytime we're using a formula, you should label your points. I know you're like, I don't need to label my points, I know what I'm doing. We like to say that, but we're humans, we make mistakes, and it's so easy to look at a number or a pair of numbers and look at the wrong ones, and it's okay if that happens. But to help yourself, it takes a second to label your points. So we have x1, y1, and then x2, y2. So let's plug it into our nifty little formula. So we have the square root of x2, so x2 is positive 3, minus x1, and x1 is negative 4. Since it's a negative, I'm going to be careful and wrap it in parentheses, squared, plus y2, so y2 is positive 2, minus y1, which is positive 5, that's a 5, squared. And from there, we're going to simplify. So that minus in the middle become plus plus. So we have 3 plus 4, which is 7 squared, plus 2 minus 5, which is negative 3 squared. We're just going to keep simplifying. So 7 squared is 49. Negative 3 squared is positive 9. Let's add like terms. So we have 49 plus 9, which is 58. If you can simplify, you must. I'll show you in the next example what that means. But I'll just tell you now, what simplifying means, an example of that, nothing to do with this example, just pulling away for a minute, making a tangent, is if we have square root of 20, that's square root of 4, square root of 5, which is 2 square root of 5. That's what we're talking about. And if you need help remembering when we do that in example 2, I do have a video for it. So just let me know or go through my videos on YouTube. So we cannot simplify the square root of 48. It is what it is, or excuse me, the square root of 58. So we have the distance equals the square root of 58 units. Now, why don't I use decimals? Well, multiple reasons. In example 1, it doesn't tell me to round. It doesn't tell me to approximate. It doesn't tell me to do anything that's telling me about decimals. All it just told me is just to find the distance. So if it's just telling me to find something or do something, it wants the exact answer. If within there it says to round or approximate or to the 100th place or 3 decimal places, then it wants a decimal. So we're going to stick with exact here because that's what it wants. It wants exact. But if it said to round, you just plug square root of 58 into your calculator and round appropriately. Alright, let's do it again. I would encourage you to pause the video and try it on your own. So pause it, try it on your own, and then press play, and let's see if our stuff matches. So because it told me about distance, I'm going to do d equals the distance formula. So x2 minus x1 squared plus y2 minus y1 squared. Now, because we're using a formula, we want to label our points. Get into that habit, especially if you're going to calculus. It's going to make your life just a little bit easier, and it's easy to backtrack and see where you messed up if there is a mistake. So we have x1, y1, x2, y2, and let's plug it into our handy-dandy formula. So we have x2, which is positive 2, minus x1, which is positive 4, and we're going to square that, and that's plus y2, which is 5, minus y1, which is negative 3, and since that's a negative, we're just going to wrap it in parentheses. And that's all squared. So let's go ahead and simplify. That minus minus becomes positive. So we have 2 minus 4, which is negative 2 squared, plus 5 plus 3, which is 8 squared. Negative 2 squared is positive 4. 8 squared is 64. We combine like terms to get 68. And we can simplify that. So I'm not going to give you like a weird number like 68 or, 175. I'm going to give you easy numbers that you can simplify, like nothing that's going to be too crazy like 68. But there's actually an easy way to use your calculator to figure out, does this have a perfect square? And I can't show you with the calculator right now, but I can give you an example by hand. So we have the number 68. So perfect squares, you're going to divide it by perfect squares. Now perfect squares are 4, 9, 16, 25, 36, 49, 81, 100. Those are 64. Those are perfect squares. So like 2 times 2, that's 4. That's why 4 is a perfect square. 3 times 3 is 9. 9. That's why it's a perfect square. So what you would do is divide 68 by perfect squares until something works out. And if you did, you would realize that 68 divided by 4 is 17. So I'm going to break this down into square root of 4 times the square root of 17. Now, if you cannot remember, or you were a little iffy when you learned this and you're not 100% confident on breaking down radicals like I just did, how we broke down square root of 68 into square root of 4, square root of 17, I do have a video for it. It's in chapter 7 of my intermediate algebra videos, which is labeled 1033. So if you look for that, it's in chapter 7. It's called Simplifying Radicals. If you can't find it, let me know. I can send you the link. But there's resources to kind of freshen up or get a different take on it if you need it. So we're going to keep simplifying. We have distance equals the square root of 4, which is 2. 17 doesn't have a square root, so we leave it, and that's units. So the distance between those points are 2 square root of 17 units, and that's the exact distance. If it wanted you to round or approximate or go to the third decimal point, that's the approximate. Approximate gives us the best, closest whole number that we can get to, that we can conceptualize. But 2 square root of 17, that's the exact solution. Alrighty, example 3. This is going to be a little bit new. We're just going to take something that we already know, which is distance, and we're going to apply it to something a little different. So example 3. Consider the 3 points. A is negative 2, 1, B is 2, 3, and C is 3, 1. We're going to plot each point and form the triangle. So let's do that. If you're asking yourself why we know how to plot points, well, it's never too bad to review how to plot points. And I'm going to kind of introduce you in a different way of thinking about plotting points. A lot of the times, we just draw a huge coordinate plane, right? We don't need to do that anymore. Let's not draw a huge coordinate plane. Let's look at our y values. So in the points they give us, we have 1, 3, and 1. So I don't need any negative y's because my y's are 1, 3, and 1. So I'm going to make my y's, and I have 3, 2, 1. And then if I look at my x's, the x's are negative 2, 2, and 3. So for the x's, I have negative 2, and then it goes to 3. And that's the coordinate plane I need. I don't need anything more than that because my points don't need anything more than that. But if you want to draw a whole coordinate plane, I don't care. I'm just trying to show you a different way to think about coordinate planes. So let's go ahead and label our points. We have A, which is negative 2, 1. Always label your points if you can. We have B, which is 2, 3. And we have C, which is 3, 1. And as best as you can, now this is the tricky part, at least for me it is connecting those dots. But I have this handy dandy ruler that can make it better. Trust me, if I don't use it, you'll know it's horrible. I need a ruler. If not, I don't even think I can get them between the points. I wish I was kidding. I'm not. If you ever see me graph on the whiteboard, you'll see. Alright, there we go. We connected those dots. Now we have our triangle. Cool, that was part A. Just wanted us to do that. And you will have to do that on my math lab, except it's multiple choice. Alright, now we need to find the length of each side of the triangle. So each side, let's look at our triangle. A side is point to point. So we have side AB. We have side BC. And we have side CA. You can do CA or AC. Guess what? You could also do CB and BA. It doesn't matter the order of letters. Just make sure they actually connect. So A to B, B to C, C to A. But we're not barbarians. We like to do A to C. I don't care how you do it. That was just a joke. Alright, so A to B. That means we're going to be using points A and points B for this. Now, I'm not going to label the points, but if you're a labeler, which generally I am, you know what I do is I say A, I just put it below. Yeah, it takes, 10 seconds to do this? But if you need it, do it. It is always good to give yourself every resource not to make a mistake, because it's so easy to look at the numbers, especially if you have a bunch of stuff going on there. So put them below if you need to. So let's plug it into our formula, and our distance formula, I'll rewrite it for us, because it says to find the length of each side. So finding the length of each side is finding the distance from one point to the next, because that's what it is. The side is point A to point B. So going from point A to point B, think of driving. Going from point A to point B, you're driving a distance. So we have the square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so let's plug everything into the formula. I'm not going to be color coordinating it here. So we have x2, which is 2, minus x1, which is negative 2, squared, plus y2, which is 3, minus y1, which is 1, squared. We're going to simplify inside. Those become positives. Oop, wrong color. So we have 2 plus 2 is 4 squared, plus 3 minus 1, which is 2 squared. So we have this 4 squared, which is 16. 2 squared is 4. 16 plus 4 is 20. We can simplify that down a little bit. We can simplify that down into square root of 5, square root of 4, because 4 times 5 is 20, and 4 is a perfect square. So the square root of 4 is 2, square root of 5. So the distance, actually we don't put distance there, we put AB. The distance between A and B is 2 square root of 5 units. And it asks that. That's what part B is asking us to do, is find the length. That's why we boxed that length. Alright, we're going to do the same thing for BC. So we're going to use B and C numbers. I'm not going to rewrite them. Let me move that down a little bit. Alright, we're going to use our distance formula, which we do have up there. So we have x2, which is 3, minus x1, which is 2 squared, plus y2, which is 1, minus y1, which is 3 squared. So we have 3 minus 1, which is 1 squared, plus 1 minus 3 is negative 2 squared. So we have 1 plus 4. So the distance between B and C are square root of 5 units. Now we can't simplify square root of 5 because it's prime, and nothing, it's just 1 times 5, that's it. Alright, last side, AC. Don't know why that changed. There we go. So A to C, we have x2, which is 3, minus x1, which is negative 2 squared, plus y2, which is 1, minus y1, which is 1 squared. So 1 minus 1 is 0, that goes away. We have 3 plus 2, which is 5 squared, and that's the square root of 25, which is 5 units squared. Oh, just 5 units, my bad. Didn't mean to say squared. There we go. We found the distances between all 3 points. That was part B. Alrighty, part C. I'm going to do it in orange. So part C asks us to verify that the triangle is a right triangle. So think about everything you know about right triangles. Think about any formulas that you can think about right triangles. Think about just triangles. What's some formulas, or maybe the word we think of is theorems of anything to do with triangles that we might know. And you might have thinking of the Pythagorean theorem, and you are 100% right. That's like the theorem that kicked off geometry, which kicked off trigonometry, which kicked off calculus as we know it. So we right now know the Pythagorean theorem as a squared plus b squared equals c squared. That's how we're taught it. But I want us to go away from thinking it as a, b, and c. I want us to actually start to think about what do those variables represent on a triangle, especially if you're going to go to trig after this. That you need to start thinking about what do these actually mean. So A and B are legs. So we have leg squared plus leg squared equals hypotenuse squared. That's how I want you to start thinking about it. It means the same thing, but we need to know that A and B are legs and C is the hypotenuse. So let's go ahead and take a look at our values of that triangle again. So you might remember that the hypotenuse is the longest. So it's the longest side, meaning biggest side. So let's look at all of our values and figure out which one's the biggest. Now, what do I compare it to? I would compare it to, I'm going to circle them in blue. So you're asking, how do I know which one's bigger? Because they all look different. You see, before we simplified it, that's going to tell us which one's the longest side. So which one's the biggest number that I circled? It's 25. So 25 is the hypotenuse because it's the biggest number under the radical before we do any simplifying. So the hypotenuse is AC squared. In this scenario, it can change. It will change. It's not always AC. It's just this, now only in this example, because coincidentally AC was our longest side, that's why it's our hypotenuse. It could be AB, it could be BC. Just go with which one's the biggest under the radical. The legs are interchangeable. It doesn't matter about the legs. both of them are the smallest, they both are legs. It doesn't matter. So we have AB squared and BC squared. So let's go ahead and fill it with the values we have that I circled. So AB is the square root of 20 squared. BC is the square root of 5, and we're going to square that. And then AC is the square root of 25 squared. Work with the values that we circled. Yet you could have used 5 for AC because it's a whole number, but I'm just trying to like really get out there. Use the values under the radical before you simplify. If not, it can be much harder. So let's just do this. You guys, everyone might remember that you can cancel those out. It's called same index, same power rule. So those cancel out, and those cancel out. So we are left with 20 plus 5 equals 25, and it does. So let's go back to the question itself. It said to verify that the triangle is a right triangle. Verify means your work is your answer. So you can't really box anything. What I need to see is the work. You don't have to give me what I put in orange. You don't have to give me the theorem. You don't have to give me that, but you have to give me the numbers. You have to show me, prove it to me with math that it is a right triangle. If the values did not equal, it is not a right triangle. Alrighty, part D says to find the area of a triangle. I'm going to do part D over here. So, area of a triangle. That might be hard to remember, especially if it's been a while. But I'm going to teach you a trick. So, let's think of a rectangle. What's the formula for that? Base times height, right? Okay, let's think of a triangle. If I cut this, don't I get a triangle? Isn't this a triangle? Isn't this a triangle? So what did I cut it in? I cut it in, you probably already said it to yourself, I cut it in half. So it's 1/2 base times height. That's the formula for area of a triangle. 1/2 base times height. Now, what are the base and height? Those are just the legs. So plug in the legs. We know what the legs were. We have the values. Use the values we used in our formula. So we have area equals 1/2 base, which is square root of 20. Height, which is square root of 5. Those are interchangeable. It doesn't matter. So we have 1/2 times, so square root of 20, square root of 5 is square root of 100. Let's simplify that. 1/2 times 10, because the square root of 100 is 10. So we have the area equals half of 10, which is 5 units squared. So the area of this triangle is 5 units squared. That's fun. I love that example. Alright, example 4. So, this is technically a midpoint question, but it's not about finding the midpoint. So, if 4, -2 is the endpoint of a line segment, and -9, -1 is its midpoint, find the other endpoint. So what this is telling me is that I have, if I draw like a number line real quick, I have a point at 4, -2, so it's about right there. And then I have a midpoint at -9, -1, that's about right there. What it's asking me is to find the other endpoint, which is going to be somewhere about there, right? Maybe a little further out. That's what it's asking me to find. Find that. Where is that? So let's think about midpoint. isn't midpoint like the middle of something? Like, if you go in opposite directions, it's going to be the same. In math, we call that equidistant, meaning if you're in the middle, whatever side you decide to go back to, it's going to be the same distance no matter what. So you can use the midpoint formula, but I'm going to try and teach you a little bit of common sense here. All right, we need to find x and y. So we have x distance and y distance. So the x distance, so from the point 4 to -9, so from here, my bad, wrong color. So from here to here, how many spaces did we move? So use your fingers if you have to. I have to. So 4, I'm not kidding, I'm doing it right now. 4, and then we have to go to -9, so we have to go backwards. So 4, 3, 2, 1, 0, -1, -2, -3, -4, -5, -6, -7, -8, -9. How many spaces or how many fingers did you count? We went backwards -13 units. Now we have to find the y distance. So the y distance, we're talking about from here to here. So from -2 to -1, that is, so -2, -1. So would you rather owe me $2 or owe me $1? I would rather have you owe me $2, but you only want to owe me $1, right? Because it's more to owe me if you're more in the hole if you owe me $2. So -2 to -1 is +1 unit. So that means from x's, from here to here, we went -13. And for our y's, we went +1. So if it's equidistant, that means we did, from here to here, another -13. And from here to here, we did another +1. So we're just going to take it, and so if we did -9 minus 13, so our x values are -9 minus 13, my bad, wrong color. So -9 minus 13, we get -22. So that means this point right here is -22. And for our y's, from y, we go from -1, and we're adding 1. So -1 plus 1, and we get 0. So -22, 0. So the point is -22, 0. Now let's actually find the midpoint. So the midpoint formula is, my bad, midpoint equals a point, and that equals x1 plus x2 over 2, and y1 plus y2 over 2. So we want to know halfway between the x's and halfway between the y's. So we have x1, y1, x2, y2. Let's plug it in. So x1 is -5, x2 is +3, y1, we have +5, y2, we have +1. Simplify. So -5 and +3 is -2 over 2. 5 plus 1 is 6 over 2. So we have our midpoint is -1, 3. Alrighty. Just like I told you, we usually end on a word problem. Usually. And here we are. And we technically did work with fractions today. Maybe not like the first day, but we technically did work with fractions, okay? Alrighty. this is zoom in perfectly. There we go. So a car and a truck leave an intersection at the same time. You know where I'm going with this. The car heads east at 30 miles an hour, while the truck heads south at 40 miles an hour. Find an expression from the distance apart d in miles at the end of t hours. So it says find an expression. It's not telling us to solve anything. It's just telling us to find an equation that can find what we want to look for. So we're not actually solving anything here. All right. It says a car and a truck leave an intersection at the same time. What that means is in math is a coordinate plane. And our intersection is right there. It tells us that the car heads east at 30 miles an hour. If you can't remember what it is, remember we have never eat soggy waffles. Or never eat shredded wheat. But I like shredded wheat. My brother eats soggy waffles. I'm not kidding. He microwaves them. I know, it's Eggos. He microwaves Eggos. He's so weird. Alright, so it tells us that we have a car that heads east at 30 miles an hour. So here's our car. It's heading east at 30 miles an hour. We'll get there, but it's heading east. And then it travels, right? We don't know where it's traveling. We'll get there. Next, we have a truck that heads south at 40 miles an hour. So we're heading south now. The truck at 40 miles an hour. So we have two things. We have the car and we have the truck. So we don't know how far they're traveling or where they're traveling. So we don't know the distance at all. So to say we don't know the distance, if I'm traveling on the x-axis, which is east, I'm moving some type of distance, right? East. I'm moving right. So I do have a distance, but are we going up and down at all? No, we're just heading east. We're not going west, or excuse me, we're not going north. We're not going south. We're just going east. So we don't go up and down at all. It's 0. For the truck, we're going down. We're going down. We didn't move left or right. Left or right represents x. We didn't do that, so it's 0. But we go down. So down means negative d. So let's label them D1 and D2. So we here have distance 1 is 30, because that's what we're doing, right? 30 miles an hour. But do we know how long we're doing it for? We don't. We just know we're doing it for a certain amount of time, and time always represents t. The truck is going 40 miles an hour, so we'll say that's D2 is 40 miles an hour, and we still don't know how long they're doing it. We're just doing it for some amount of time. So if those are the D's that represent the D0 and 0 negative D, those are the D's we're talking about. So if we made a point, it would be D, which is 30t, and we don't know anything. They're not doing anything else. They're not going up or down. So we only have d, so 0. And then for our truck, it's 0 because we're not going left or right. But we are going down, and that represents negative d. We have our d, but since it's negative, we'll be doing negative 40t. And those are our x1, y1, x2, y2. So if it's asking to find an expression for the distance, remember the distance means distance formula. So let's plug our x1s, y1s, x2s, y2s into our formula. So we have distance equals our square root. So x2, which is 0, minus x1, which is 30t, squared, plus y2, which is negative 40t, minus y1, which is 0 squared. So let's simplify. We have negative 30t squared plus negative 40t squared. Negative 30 is 900, and t squared is t squared. Negative 40 squared is 1600, and t squared is t squared. We can combine these, so we have 2500 t squared. The square root of 2500 is 50. T squared, the square root of that is t. And the one thing that I'm going to be a little stickler on, we have to put d of t, because it's telling me distance of time. So how much we're doing it for represents the distance that we're achieving. So that is our expression.